Here are the rules for how to use try and catch. First, any code that you think might throw an exception should be wrapped in a try block. And then that try block should be followed by one or more catch blocks. How do you know code might throw an exception? You need to know the code. If all you're doing is formatting some strings, what could possibly go wrong? But if that code is going to try to open a file, maybe the file doesn't exist anymore, maybe the user doesn't have permission to open it, even though they had permission to browse to it and tell you its name. If that code's going to do a calculation, is there a way it could divide by 0? Is there a way that it could suffer a numeric overflow or underflow? If it's going to deal with a collection, is it guaranteed by the structure of your loop to go through only the bounds of the collection, or could it get out of range? It's your judgment to know that your code might throw an exception, and that'll probably include reading the documentation for the functions that you're calling. Remember, you want to have your catch as close to the problem as possible, but don't put a try catch if there's nothing you can do when you run into trouble. If you're deep in the bowels of some business logic and you're going to catch an out-of-range exception, what are you going to do about that? Now, maybe you'll throw a different exception that's more appropriate to your circumstances to gather more information to the code that called you. But maybe you've got nothing to say. In that case, you shouldn't have a try catch here. Don't interfere, and whoever called you can have a try catch, and they'll deal with the problem. You can have as many catch blocks as you like, as long as you have at least one, and go off the more specific ones first when you have exception hierarchies. And although in theory you don't have to have exception hierarchies, I consider it to be a best practice to do so. Another best practice is to catch exceptions by reference. I did that in the demo without explaining it. Now I will show you why that's the right thing to do. So in general, your code's going to look like this. You have a try in which bad things might happen, and this may call down, 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 down. It may be 6 function calls away that the bad thing might happen, but putting a try in, you're saying, I know what to do if something goes wrong. Then you catch a most derived exception, possibly a less derived exception, like the exception class in the standard library from which all these exceptions I'm using derive. And you react appropriately. That may mean that you go back around again on a loop. It may mean that you put up a message to the user. It may mean that you completely bail on the application, but perhaps you give people a chance to save their information first. That will depend on the application that you're writing. C++, as you probably know, gives you a great amount of flexibility and control. That's not always what you want. So the way the language is written, you can throw and catch anything. And back in the day, we did. You would throw the number 3, and there'd be some try block somewhere up above you that would have a catch that caught integers. And that individual developer knew that, hey, when I catch an integer, here's how I can understand what 3 means as opposed to, say, 5 or 142. And a different piece of code would throw a string, like index out of range. And somewhere up above it, there'd be a catch block that was catching a string and would take it apart and parse it and figure out what on earth it meant. That was actually quite awful. It really was. It obviously makes more sense to throw an object that has within it some codes, maybe for severity, a string to show to human beings, maybe some other meta information like what overall class of error this is. Having to figure all that out from scratch on every application and keeping track somewhere of which things throw integers and which throw objects and which throw strings, it was awful. Sometimes the documentation would help you. Most of the time you would sort of read the code. So it was a big improvement to have exception classes added in the standard library. So the class exception is the base class to a whole hierarchy of exceptions. And what actually get thrown throughout the standard library are instances of classes that are derived from exception. And that's what you saw in the demo with vector. Vector throws an out-of-range exception. Out of range is one of the classes that derives from exception. The wonderful thing about this approach is that you can catch instances of the base class. You can say, oh, just give me exception, and catch a wide variety. But you can also catch more specifically if you want. It's a level of precision that's just not available when you're throwing integers or strings. You can, and I mean should, use these exceptions as well in your own code. Standard exception is defined in the header std except. As you saw in the demo, there's this useful function what that gives you back a string. That string is suitable for showing to human beings in error messages, and it's also super useful while you are debugging. The real purpose of exception is to be the base class to some derived classes. And specifically, there are 2 derived classes and then a number of very specific exceptions that derive from those. So the first derived class is called logic error. And here you see things like you gave me an invalid argument. Maybe you gave me a 0, which doesn't make any sense because it's supposed to be 1 to something. Maybe something's too long or too short or they're out of range. It's easy enough to argue about should vector throw out of range when you give it 99 and there's only 1 element, or should it throw invalid argument because the 99 is clearly invalid? And if you like those kind of arguments, you can go ahead and have them amongst your friends. Don't really try to work out what kind of exception something throws by logic. Try to work it out by the documentation or by doing it and seeing what you catch. Vector throws out of range when you pass the wrong size number to its at function. That's just what it does. Now, there's another set called runtime error to handle things like underflow and overflow. The interesting thing about all of these classes that inherit from exception is they don't add anything. They don't add any new member variables. They don't add any new member functions. The only thing they have is their name. But that lets you tell them apart, because you can catch an out-of-range exception and you can catch an underflow error in different catch blocks because they're different types. And then just call the what method because that's about all you have available to do. But you could also do your own logic. Hey, if I got an underflow error, then that means whatever it means in your application, and here's what I have to do about it. So telling them apart strictly by their class name makes them what we call marker classes, but it's a really useful capability. To show how to throw an exception from your own code, I'm going to use the person class that I've used in other demos before. A person has a first name, a last name, and an arbitrary number, which carries no meaning at all. It just gives me an opportunity to pass integers around. I've modified my person constructor a little bit. I take first name, last name, and arbitrary number and save them into my variables, but I've added a body to the constructor. And in this body, I test to see if the arbitrary number is 0, and if it is, I throw an exception. Now, in order to be able to throw this exception, I need to include standard except, and I'm throwing the invalid argument exception, which inherits from the exception class. And the constructor for this exception, like all of them, takes a string, and I'm passing in this one. Arbitrary number for a person cannot be 0. Let's go into the main, and somewhere before this bad thing happens here, let's construct a person that deliberately breaks those rules. So I'll make a person called Kate. And provide an arbitrary number of 0, knowing, because it's a demo and I want the bad thing to happen, that this will trigger the throw down inside the person constructor. Now we still have a catch block left over to catch an out-of-range exception that happens when this line is executed, and I have my generic, hey, catch any exception that inherits from the class exception. We'll leave them both there and both with their breakpoints, and I'm going to run the application. So let's start stepping along. You can see that as soon as we tried to construct the invalid person, Control jumped down into this catch block. We totally skipped the line of code that was trying to get to the bad part of the vector. That's an important part of exceptions being thrown. Nothing else gets run. And we're down here. We did not get caught in the out of range exception because that wasn't what we triggered. We triggered that invalid argument exception. If I hover over E, you can see the message there, arbitrary number for a person cannot be 0. And if I expand it out like this, you can also see that it says here invalid argument. That's an important piece of information. I only caught the exception as an exception, not as an invalid argument, but I can still see its type. And that's because we've caught it polymorphically with the reference. We caught it by reference. In fact, let me show you what happens if I don't catch it by reference. Just take that symbol away and run. No other change. We still end up in the catch, and that's why leaving off the punctuation is sort of a seductive error, because hey, I caught the exception, that's great. But if I hover over it, I still see that same message, arbitrary number for a person cannot be 0. But if I expand it, you'll notice we no longer notice here the class name of invalid argument. We lost that information. We've actually suffered slicing. Talked about slicing when we were talking about polymorphism. Now, since there are no extra member variables or member functions in the derived classes from the standard exception class, you may think slicing doesn't matter, but we lost the type. We lost that it was an invalid argument. And if this string was something like, boy, are you stupid, then we wouldn't know anything at all about what had gone wrong. That's why when you're catching exceptions that are in a hierarchy, simply remember to always catch them by reference so that you gain the benefits of polymorphism and you don't suffer slicing.